Hi, welcome to the Calculus 3 lecture series. And we are in the unit number 3, multiple integrals. This is our second video and it's lecture number 2. And last video we talked about how do we do the double integrals over a rectangular area. And today in this video, we're going to talk about how do we do the double integrals over general regions here. Okay, so now let's take a look at our worksheets and the type of the problems we have here. Okay, so you know that let's try to kind of refresh our memory what we did in the previous. Okay, so in the previous one, okay, so if you integrate over, you double integral over rectangular regions, that means your regions here, right? So this is X, this is Y. So X is from A to B and Y is from C to D. So basically you are integrating over this area. So we know because of this is rectangular areas, it's pretty simple. So we just say here we do the f of xy's, right? So it depends on you do the dx first or dy first. So it doesn't matter if you do dx first, you start with the axis bound, right? So AB and CD, or you can do, if you want to integrate f of xy dy dx first. So if you do the dy first, then your limit here is CD and the AB's here. And also by the Fubini series, we say if x of y, they are continuous. So you can switch the order of the dx dy's here. This switched order, you know, we're going to be pretty handy and very helpful when our integrations regions is not as nice as rectangular regions here. All right, so today we're going to talk about how about if I have a general type, you know, it's not a rectangular. So in here, we have two basic kind. We call it type 1 and type 2 here. So for the type 1s here, you know, your x bound still is fixed. Your x bound still is from A to B here, but your y bound here, right? So your y bound instead of C to D, it was bounded by two functions, two of the x functions. So for this type of the situation, you want to integrate the y first. So when you integrate y, I typically will draw a picture like here, from here to here, you integrate the y's, right? So that's why your lower bound here will be the g1x to the g2x, right? So you kind of continuous integrating the y direction. Then after that, then you kind of integrate out the x, so it's A to B here. So this is what we call this the type 1. So the type 2s here is the y in here. So the y in here, y have the fixed bound, C and D. Then what happened to the x here? The x bound is based on what? It's based on the function. So that's why, so for this type of the regions, then you will go this way. You integrate the x first, right? So when you integrate the x, that means that you need to change the x to a function of the y. So that's why you have from h1y to h2y. Then afterward, then you integrate out the CD. Right, so that's the y boundaries here. So like sometimes you will ask us, how about the some integration region is not good as type 1, the type 2. It's not rectangular neither. So for the region, like any general regions here, so that's why sometimes you need to divide by, you know, you need to divide your region into several small regions. And then each region you can either use type 1 or you can use type 2 here. And we will see some examples here. Okay, now let's take a look at our first problem here. So I want to evaluate the 2y minus x, and the x and the d, the integration regions here, the d is this half circles here, right? So how do I do the d? This is the half circle. So this is a type 1 things, because of why? Because here this is a type 1, it's because my x bound is fixed, right? So my x bound is fixed because it's the half circle. So I know my x bound is from the -1 to +1 here, right? Then my up bound is different because this one's here, my bound here, this is x squared plus y squared equal to 1. So I have y squared equal to 1 minus x squared. So y is equal to the square roots of the 1 minus x squared, or y is equal to the -1 minus x square roots, right? But in here, I know, you cannot, you cannot have negative. So this one is not going to work. So I know the boundaries here is the y boundaries from 1 to 1 minus, from the 0 to square roots of 1 minus x. So, okay, so now let's try to write it. So how do I find these integrations here, right? So this is 2y minus x. So in here, I need to do the y first. I need to integrate this out. So y is from here and here, right? So this is how the y directions, right? So now let's try to, so in here, that's why I'm going to put this is dy. So the dy is here. So where's the y start? Y start with 0. So then the y going to end at this curve. So what this is a curve here? This is 1 minus x what? 1 minus x squares, right? Okay, and then now after you integrate out, and then you integrate dx. So now after that, so your dx is range from the -1 to where? To +1 here. Okay, so now let's take a look at how do we do the integrations here. So let's still, because I'm integrating to the y, so x is a constant. So the first term will be y squared minus yx. And then I put the upper bound and the lower bound is 1 more square and the dx here, right? So you plug this one in, and then you will simplify this a little bit, and then you will find this will be 1 minus x squared and minus x times 1 minus x squared dx here. So now you can separate this one into like 3, right? So this is -1 to the 1. This is x squared, and then this is minus x square root of 1 minus x squared dx. So in here, the purpose is not to teach you how to do the integrations, okay? But in order to integrate this one, you can use the u sub, okay? So all the other integration is pretty simple. So you find it, and then you put the upper bound and the lower bounds, and so finally the integration will be x minus x cubed over 3 plus 2. This is 1 minus x squared and 3/2. Then you put your upper bound and lower bound, and the answers here is 4/3. Okay, that's it. Okay, so now, so this is pretty easy, right? So now let's take a look at this ones here, right? So this ones here, let's see how do we do that. So this is my regions, right? So let's take a look. I said, okay, if I want to do the dy first, right? So if I go to the y direction, let's see it work or not. So if you go from here to here, so okay, so here they all reach what? They all reach from 0 to x, right? But take a look here. After you pass this point, if you still do the y, you still can do that, that's fine, but then you need to change your up bound to these lines here, the 2y plus x, these lines here. So that means you really need to separate this, if you want to do the dy first, that means you really need to separate this one to a 2, right? 2 double integrals. So one is you doing from this regions, right? So you do a y first, then other one you do from this region because the up bound is different. So I know, okay, so that's the how do you do y? Yeah, of course you can do that. How about now let's take a look if I do the x directions, right? So the x direction, that means I'm going this way. That's pretty good. It's pretty consistent, right? So my x direction, what I start on this line, right? I start on this line, right? Then where I end on this lines here, right? So I know for these ones here, probably it will be easier, you know, if I do the x integration first, all right? So let's try to write these ones here. So that means, okay, I can write these ones here. So this is x plus y dx, right? So we decide we're going to do the dx first because it's from the x direction, so this one's easier. Okay, so this one's here is start from y equal to x. So I know my limit is the lower bound is y. Then I end in this line, 2y plus x. So this is x is equal to -6 minus 2y's, right? So I can say 6 minus 2y's here. That's how do I do dx. Now after I finish dx, then I will do, I integrate the y. So the y is from the here, right? Y is from here all the way to what? All the way when you finish the x is here, so it's all the way to what? It's 2 here. Okay, so after you set it up, then the integration pretty easy here. So you just say this is 0, 2. Now I'm taking the derivative, I'm taking the integration for x, so y is a constant. So the first time you have 2x squared plus xy. Then you have 6 minus y and y, the upper and the lower bounds here. Now, you substitute the upper and the lower bound and simplify it a little bit. So you will get it's 18 minus 6y minus 3/2 y, right? And the dy is here. Now you do one more time integration. This is 18y minus 3y squared minus 1/2 y cubed. Then you have a 0 to 2. So when you substitute this, and you will get a 20. Okay, so that's what is this integrations here. Okay, so now let's take a look at another part C's evaluation. So this one, they already tell you the boundary. So here we just need to know which one to integrate first, right? So I'm integrating the y first, okay? So now this, okay, so let's start here. So this is 0 pi over 6. So what is the cosine you integrate y will be what? Will be sine x plus y here, right? And then from the 0 to x, then the dx, then you substitute, and so you will have this one's here. You will have, this is negative 1/2. Okay, so this is a sine x, so this will be okay, so this will be, so hold on, so let me see here. Okay, so this will be 6 pi over 6 sine, you integrate, you put here x, so sine 2x. So you have a sine 2x minus sine x Now you do dx here. So the sine 2x, it will be negative 1/2 cosine 2x, and then plus cosine x, it's right, then 0 to pi over 2 here. So you plug the numbers, and you will have, oh, this is pi over 6. Here, pi over 6. Then you plug number pi over 6 and 0, and your final answers here will be 2 square roots of 3 minus 3 over 4. It's very mechanical after you just plug the number. So you just need to remember when you do the y integrations, right? Then you treat the x as the constant here. Okay, so now let's take a look at the next problem here. So the next problem, they just say write it out. They don't really want you to carry out the integration. They said write out the integration if the region D is bounded by here. Okay, so let's take a look before, right, before we know what is the region. Let's take a look here. Okay. Okay, so this is the 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 here, 6 here. Okay, so y equal to x here. So this is my first line here. Right, so this is y equal to x. Okay, y equal to 5x is here. Y equal to 5x, x equal to 1, y equal to 5 here, x equal to 0, y equal to 0. So this is the y equal to 5x. And then the x plus 1 equal to 0. Okay, so the x equal to 0, y equal to 0, y equal to 0, x equal to 0. So you will have, oh, this one's here. I hope that I can graph it. Okay, so oops. All right, let's see here, 6, 6 here. So maybe start here. Okay. So this is x plus y equal to 6. So the regions we want to integrate is here. Okay. Okay, so for this ones here, so you see here, so let's take a look, right? So if I want to do the y direction, so you can go here, and go here, go here. So if you take the derivative of the y first, the starting point is pretty good, is this line. But then also when they touch this point, then you need to change the up limits, right? So that's will be the problems here. Then how about you say, okay, let's try and to see, you know, if, okay, so here is this, all right? So you say, how about let me try to see the x direction. Okay, if you do x directions, you start here, you integrate here. The same way, when you pass in this point here, then your upper limit will change here. So either ways, right? So either way, you are going to separate these two to how many? You need to separate these to the two regions here. So the region I'm going to separate is what here? So this will be the here. I know my graph is not quite right here. So this one's here. So this is the point. Where is this point? So this intersection point is 1 and what? 1 and 5 here. And this intersection point is 3 and 3. So you can plug, you know, you can solve this, okay? So now I decide I have to change to the two, you know, the two regions here. I need to have this yellow region and I have this green regions, right? Okay. Okay, so now let's take a look. So for the yellow regions here, so let's say here, this is the D1, right? Okay, so this is, I call it a D1 region. So for the D1 regions here, let's see here, Y is a variable. So the X is from 0 to 1. Now what is the Y? Y is from this blue line to the green lines, right? So Y is from X to 5X. Then this green one, I call this region 2. So D2 is here, take a look. Y is from what? Y is from the blue line again to these red lines, right? So red line is equal to that, 6 minus 1. So what is X? X is from 1 to where? To 3, right? Okay, so now let's set it up. Okay, so we don't need to solve it. So this is x squared y squared dA. So I can set it up. I will say this is x squared y squared. So in here for D1, I'm integrating y first and then x. So y is from 5 minus x to the 5 minus x, then 0 to 1, that's the x. Then the same way I can separate from the D2s here. So I'm still have a function x squared, y squared. I'm still integrate dy first and then dx. So the x, y is from the x to the 6 minus x, y is 1 to 3, right? So let's color code here. So this is my what? This is my yellow regions, and this is my green regions here. All right, so this is how do you separate the the separated regions, and so it's not belong to. So this triangle does not belong to type 1 or type 2, so you can separate that. Okay, now let's take a look at problem number 7. So it's also we want to write it. Okay, so these ones here, they say separate this one, write it out. If the integration region is the first 3 quadrants of a unit circle. Okay, so if it's 3 quadrants of the unit circles here, okay, so then let's go ahead, draw my things first, right? So this is the first 2 quadrants. So this is my integration region, x squared plus y squared equal to 1 here, right? So the less than equal to 1. Okay, let's see how do we do that. So first things here, all right? So you see here, let's try to see the y direction. You can y see here, y here, y here. Then from the y, from here to here, from here to here. So the starting point is different. So I know if you do the y direction, I need to have 2 regions. Okay, so let's go to see. Let's see if I do the x direction. Will that be a little easier? All right, so x directions here. All right, so the x direction, I'm gonna go here. So this way, this way, this way, and this way. So the x direction, I also have 2 regions, right? So I know either way, I need to really divide this integration regions to what? To the 2 parts. So I can do it, right? Okay, so now let's color code that. So this little region, the first quadrants here, let me color code with yellow. And this half circle here, let me color code with the green here, all right? So this one, I code is D1. This one, I code is D2 here. Okay, so let's take a look at the D1s, right? Okay, so let's write it out. After you write it out, then you will be able to take the integration quite easy here, all right? Okay, so for the D1s here, okay, D1 is these yellow ones, right? So my X is from 0 to what? 0 to 1, right? This is unit circle. Then my Y is from 0 to what? Square roots of what? 1 minus x squared, correct? All right. Okay, so now for D2s here, this is my green one. So D2, if I want to do, you know, like, if I want to do the X here, right? So the in here, this one's here, so this, the X would go this way, this way. So it's all start with 1 minus y squares, right? Okay, so then what is the y? That's the y is from -1 to 1, right? Now let's take a look at x here. The x is equal to 1 minus y squared, right? So the x here going to be positive 1 minus y squared or negative 1 minus y squared, right? So now I know I can, you know, so I can do like this is here. So we can say this one's here, we can say the x is here, right? So if I do the x first, okay, so my x here is from the negative 1 minus y squared to what? To the positive 1 minus y squared, right? Okay. Okay, so now let's try to put this integration together. Okay, so the first integration, region 1, let me do y first, right? So it's x squared y squared dy, because y is from here, right? Okay, so now y is from 0 to 1 minus x squared. Then I do dx. Dx is from 0 to 1. So let me color code in here. So this integration is my yellow region. And then I plus, okay, now I want to do x here. So I have x squared, all right? So I have an x squared and y squared dx dy. So x here is from negative 1 minus what? Y squared and to the positive 1 minus y squared. Now what is the y's here? Is negative 1 to the 1 here. All right. Okay, so this is what is my green area. Okay, that's it. All right. All right, so let's take a look at our last problems here. They say use the irrelate the integral to find the shaded area. Okay, so the shaded area. So see here, this shaded area, my x is from 1 to 4. All right, so then my y equal to 1 over x. So if I'm integrating for the y direction first, right? Okay, so let's take a look here. So now this one's here. I want to find the area, find the shaded areas, right? So I know if you have a f of x, y, if you have of f of x, y, so then if you put a f of x, y's here, then what you find in here, you find the volumes, right? So like in here, let's see here. So I'm going to integrate the dy first and the dx. So y is from where? 0 to 1 over x. And x is from where? It's 1 over what? 1 over 4. So if f of xy has some function, right? So if x and y have some functions, then these things here we are integrating is volumes, right? But now they are looking for what is we want here? We want is this areas, right? So if this is the area, what's that mean? That means my f of xy function is equal to what? Is equal to, is equal to 1, right? It doesn't have any functions here. So just back to a calculus 2. So you integrate 1/4, 0, 1 over x, then it's 1 dy dx here, right? So that means in here you don't have any, so there is 1s here. That's how you integrate your function of to get the areas here, right? Okay, so now you can do the calculations, and this one's here, this is 1 over 4, and then integrate y is 1 over x and 0, and you can get it's a natural log of 4 here. Okay. Okay, so now in here, I want to write it out something for you. So based on this example, we can say the area of D, of region D, okay, in the plane, okay, you can be written. So if you want to use a double integral, so it can be written as what? You integrate a double integral over the region D. Now here is 1, okay, dA, okay? So then you can evaluate that. So it's importance here, right? So because it's 1, so you are looking for the area of the region D. So it's back to what we learned in the calculus 2s, right? Okay, so that's it. So this section is a pretty simple, easy section also. So the emphasis here is not to teach you the integration skills, right? Because I assume you know all these integration tricks. And the purpose for this section is to recognize how do you set the boundaries, right? So like you can take a look at your integration region, and then based on this integration region, you can figure out which way is easier for you to do the integration. You go X first or you go Y first. So whenever you do that, then your boundary has to change with that, right? So depends on the functions, right? So which function it will be easier to do. Okay, so that's it. And I hope this one give you some, set you some background when we continue to do the integration. So, all right, so make sure, you know, if your region, so the integration region, graph it first, then decide which direction you want to go integrate first. All right, that's it. Have a nice day. Okay, bye.